It's paper 62531 May June 2024, paper 3. Okay, so first question. Figure shows a speed time graph for a car. So it's given. Okay, for the graph, match the letter R, S and T with motion at the point and draw one line for each letter to the correct description. One has been done for you. Okay, so it is starting from 0, it's increasing, so it's acceleration. Yeah, it's been marked here, it's R acceleration. Okay, and from R to S, the S is standing here, no movement, so it is at rest. Okay, and T, it's sloping down, so it may be negative acceleration or deceleration. Okay, very simple. Okay, determine the speed of the car at the time 4 seconds. Determine the speed of the car at 4 seconds. Okay, speed is equal to, from the speed you can calculate, it is from the graph, I think for speed 4 seconds. Okay, I think it's approximately 17.75. Okay, next question, determine the distance moved by the car from the time 16 seconds to 20 seconds. 1 minute, I will go to the question and then we will come back. Okay, so 16 seconds here. Okay, this point, straight line directly it is hitting, and 20 here. For 16 it is 20 meter per second. This is for 16, and 0 for 20 seconds. Okay, so now to go to the calculation, I'll do the calculation at the bottom. Okay, so time is 20 seconds minus 16 seconds, and the distance moved, speed is equal to, it starts from 20 meter per second and reduces to 0 meter per second. Okay, here it is 4 seconds, here it is 20 meter per second. So distance moved, D is equal to, it is 4 into 20, right? It is 80 meter per second. Yeah, answer is 80 meter per second. Sorry, not meter per second, it is meter alone. 1 minute. I'm a little bit confused, so it's meter alone. Okay, define the term velocity. It's simple, it's rate of change of object. That's all, simple. Can we go to the next question? Rate of change of object. One more thing we have to write, it is with respect to time. Okay, next question. A student places six 100-gram masses in a stack as shown in the figure 2.1. The height of the stack of masses is 5.4 centimeter. Calculate the average thickness of one mass. So it is how to calculate the average thickness. Total is 5.4 centimeter. I will write it here, 5.4 centimeter. So totally it is 6. So I divide it by 6 for each. I am getting the answer 6. So it is 0.9 centimeter. Okay, totally is 6. So I divide it by 6 here. The figure 2.2 shows the masses, a measuring cylinder and a beaker containing some water. Okay, these stacks are here. Okay, the student uses the equipment to determine the total volume of 6 masses. So how will you find out? So we will first step I am writing here. Okay, pour the water. Okay, pour the water here, measure the height. Okay, then put the stack inside it. Okay, then measure the increase in volume. Finally define the differences. That's the answer for the question. Okay, so pour water into the measuring cylinder. One part, okay, measure the height, I write it as h1, okay, then measure the height. I think here I have to write measure height h1. Second thing, now place the stack inside the water in the measuring cylinder. Place the stack inside the measuring cylinder with water. It should be immersed, okay, into the water. So now measure the height is h2, okay, now h2, but it is changing in the volume. That's the condition there. Volume is v1, now the volume is v2. Here is v1, here is v2. So final volume difference is v2 minus v1. Okay, v2 minus v1, that's the difference in the volume, which gives the volume of the, which gives the measuring mass of the stack. Okay, next question. The figure shows the horizontal forces acting on a boat. Okay, here is an 80 Newton backward and 200 Newtons forward. Calculate the resultant horizontal force on the boat. So resultant force, how will we calculate? The size of the resultant force, how will we calculate? The larger force minus the smaller force. So 200 Newton minus 80 Newton, it is 120 Newton. So we have to also mention the direction here. Okay, Newton they are given, so I no need to write. Okay, now the direction of the resultant force. Which force is greater? So towards that side, boat will be moving. So automatically forwards, the boat will be moving, or towards right. Suggest what causes the 80 Newton force on the boat. What causes the 80 Newton force? Okay, this force is caused by the friction or the drag force. Okay, friction or drag force. Okay, either from air or water, whatever it is. Both are creating it to move it in this backward direction. Okay, another boat is traveling under horizontal forces on the boat are balanced. Describe the horizontal motion of a boat. So what is the horizontal motion? It's the result of a tendency of any object to persist the motion at a constant velocity. It's a steady uniform velocity. Simple word. Okay, it's a steady, constant. I'll write simply steady, constant or uniform velocity. This is the simple word to explain. But when we write horizontal motion, okay, is a result of any object to persist the motion at a constant velocity. That's all. Write it simply. Please don't do it in the exam. Okay, can we go to the next question? Here is a wheel used to steer a boat. Okay, figure 3.2. The force is 60 Newton, acts perpendicular to the distance. Here it is acting. Okay, the distance is 50 centimeter from the center of the pivot. Okay, calculate the moment 60 Newton force about the pivot, include the unit. So we know, first write the formula so that you can able to find the answer. Moment is equal to force into perpendicular distance. Okay, here from the center of the pivot. Okay, so force is 60 Newton given into the perpendicular distance is 50 centimeter. So it is, so Newton centimeter. It is 3000. Here we will write, okay, 3000 Newton centimeter. Okay, unit is Newton centimeter. That's what you have to or if we convert to Newton meters, it is divided by 100, so it is 30 Newton meters. Unit is Newton meters or Newton centimeters, depend on the answer you are giving. Okay, if it is 30, it is Newton meters. Please remember and write it. Next question, fourth question. The government of a country decided to reduce the amount of fossil fuel burned for generating the electric power. State 2 reasons apart from the cost for reducing the amount of fossil fuel to be burnt. Very simple. Fossil fuels are non-renewable energy. 1 point, maybe you have to write it. Second thing, if you are burning the fossil fuel, it will create an air pollution, okay, and it create global warming. So we will write these 3 points to get, I think, 2 marks only. So write 2 points but clearly. Okay, I'll write fossil fuel contribute to global warming. Okay, 1 point, and it contribute to, similarly, fossil fuel, I write 1 more point here. Okay, same thing, contribute to atmospheric pollution or air pollution, whatever it is. This is second point. If you want, you can stop here, or your basic idea. Third one, we can write it. They are non-renewable energies sources. Okay, okay, those are the 3 points you have to write. Okay, remember, global warming, atmospheric pollution, and non-renewable energy sources. Okay, describe how a hydraulic power station work. Very simple. Water is stored in the reservoir, okay, or the dam, wherever it is used. First point, water is, I am writing in a simple way because the space is squeezed. Okay, please don't write it in this chemical formula. Water is stored in the dam or reservoir. First point, it is there. It is having some, I am writing continuously, having, it is means in the sense, I will write it clearly, don't want to write it here. Okay, water is having some potential energy. Okay, that is to be remembered. Water is having potential energy. It flows, the water flows, okay, through the pipe. It is called penstock. Okay, from there, which moves the turbine or which passes through the turbine, passes through turbine. Okay, passes through the turbine or spins the blades in the turbine. That's its clear answer. It spins the blade in the turbine. Okay, spins the blade in a turbine, which in turn generates an ultimate, which in turn produce the electricity, which in turn produce electricity. Okay, so first one, in the dam, it is stored having some potential energy. Okay, from there it moves through the pipe. From there it passes or spins the turbine blades. Okay, spins turbine blades. Then which in turn produces electricity. Okay, 4 steps you have to write it. Hydraulic power stations are expensive to build. Okay, state 2 disadvantages of using hydroelectric power station to generate electrical power. So what are the 2 conditions you will write? It covers a large area of the land, and sometimes it may be largely flooded, and then relocation of the population to build the hydroelectric power station there. The habitats of both the people as well as the animals, both in land and water, get mainly affected. Sometimes it creates drought. Okay, These are the things we have to write. I will write 2 points. One, large area of the land is flooded when it is least or when it is of storage capacity higher. Large area of land flooded. 1 point. And relocation of the people to build the hydroelectric plant. Relocation of the population. Second point. Maybe third one, damage to the habitat, both land and water. Okay, I'm speaking about the damage to the habitat. I will write here. If you want, you can take into consideration damage to habitat, both in land and water. Okay, these are the conditions. Okay, the government uses the 1 minute. The government plans to build some wind turbines. The government plans to store some of the electrical energy generated by the wind turbine. Suggest one method of storing electrical energy generated by the wind turbine. One is the battery storage. Okay, one may be battery storage, using large batteries to store the energy, electrical energy. Second thing, pumped hydro storage. Okay, pumped hydro storage. This is a method. Here electricity is being used to pump the excess electricity is being used to pump the water from the lower reservoir to a higher reservoir, effectively storing the energy. Okay, this is one of the cheapest method they are using. Least expensive method, this one. There are different methods. One more is, I think, compressed air storage. Compressed air storage. Okay, CAES. Compressed air energy storage. I forgot the name. Okay, yeah, CAES. I remember only the short form. These are the 3 methods. One is battery storage. Second one is pumped hydro storage. Third one is compressed air storage. Okay, next question. Describe the arrangement, separation and motion of a gas particles. I think, right? Yeah, gas particles, how they are arranged. First one, on the arrangement, they are widely spread, okay, compared to solid and liquid. Compared to arrangement wise, I am writing gas particles are widely spread, okay, compared to solid and liquid. 1 point. And separation, they are moving randomly. They are having more space, so they are moving randomly. Okay, colliding each other. And along the walls of the container. There they are stored. Okay, these are the properties. Okay, and they may have high kinetic energy to move and hit the walls. Okay, one more point if you want. High kinetic energy they have. Now the B question, 5th B, show some gas in a container with a piston. The piston can move into the container. Okay, it's moving here. A force of 30 Newton pushes the piston into the container for a distance of 0.8 meter. Okay, force is given 30 Newton and the distance is given 0.8 meters. Now calculate the work done. First write the formula. Work done is equal to force into distance moved. So force is 30 Newton, distance is 0.18 meters. So answer is 5.4 joules. Okay, or Newton meter joules. Okay, when the piston moves into the container, the temperature of the gas does not change. Describe and explain any change in the pressure on the wall of the container. as the piston moves inside, okay, the pressure increases because the collisions are more frequent. As the piston, okay, moves inside, we have to write clearly, moves inside, the pressure gets increased. Pressure increases because, or the reason is because the collision are more frequent, okay, more frequent. Okay, that's all the reason. A student wants to compare the conduction of thermal energy through the rods made of iron, copper, and glass and aluminum rod. Each rod is coated with the wax. Okay, describe how the student can compare the conduction of thermal energy through the rods. Here it is been burnt, so automatically the wax will get melted after a certain time. So one thing is how much wax it melts or how much time it takes to melt the wax. Both things to be conducted, or the shorter the time it melts for the wax. Okay, depends on this condition only, is the time and the amount it melts. Amount we cannot measure, so time we can take into consideration here. Okay, as the rod is coated with wax, the temperature starts to rod is coated with wax. Okay, one point with this which we have to measure. As temperature rises, increases. As temperature increases, wax starts to melt. Okay, measure the time to melt the wax. That's the reason. Measure the time to melt the wax. Melt the wax. This is one method how quickly it melts. Okay, means one thing we have to write how quickly it melts. Better conductor means it will be quickly melting. I will write here. Okay, better conductor means it conducts fast, so quickly it melts. Okay, and shorter the time it takes. Okay, better conductor means quickly it melts, shorter the time it takes. These are the two conditions we have to take into consideration for measuring the answers. Okay, which one is good conductor? That's the answer I am saying here. Okay, the B question, Bunsen burner emits infrared rays. Okay, the infrared waves has a wavelength of 2 into 10 power minus 6 meters and the velocity of the infrared rays is 3 into 10 power 8 meter per second. Calculate the frequency of the infrared particles. How will you calculate the frequency? Frequency formula with respect to wavelength and velocity. So wavelength is given, okay, wavelength given as well as velocity is also given. So frequency equal to, frequency equal to, what is the formula? It is frequency is equal to velocity by wavelength. Okay, generally wavelength into frequency is equal to velocity. This is the formula, but here according to the condition we changed it. So it is velocity is 3 into 10 power 8 divided by 2 into 10 power minus 6. So your answer after conclusion will be around 1.54, right? I have 1 point, no, I made a mistake here. It is, little bit time taking, 1.54 into 10 power 14 hertz. Okay, this is the answer for this question. State the name of the region of electromagnetic spectrum which has a wavelength longer than the wavelength of infrared. Give one used radiation of this region. What is the wavelength we have? The infrared. Okay, so infrared, after infrared we have infrared. I'm going this way, which is bigger in the wavelength. So second one is bigger in the sense higher, longer wavelength. Okay, microwave we have. Other than that, we have radio waves. Okay, infrared maybe 10 power minus 5 wavelength. Here 10 power minus 2. Radio will be 10 power 3. Okay, so I go with the radio waves for my question answer. Radio waves I'm using. Okay, and the wavelength is 10 power 3. Okay, they are asking one use. It's very simple. Telecommunication purpose. Okay, that is in mobile phones, FM, TV, whatever it is you write, the answer will be there. Seventh question shows a ray of light striking a plane mirror. Okay, it's going and striking a plane mirror here. Okay, the ray is reflected as shown. They also given the ray of reflection. The angle of incidence for the ray of light is 40. Indicate the angle of reflection drawn by the letter R. This is angle of incidence I up to the center normal point. Here this is angle of reflection R. Up to this is angle of I incidence. This is reflection. This is the normal N. Okay, then the second question here, state the size of angle of reflection. The light reflects back to the mirror. Here light reflects to the mirror. At the same angle it hits the mirror. Okay, so here it is same ray of light. When it hits the plane mirror, it reflects back the same angle. So the angle of reflection is equal to angle of incidence. Okay, as it hits the plane mirror, I is equal to R, so it is 40 degree as it hits the plane mirror. Okay, next question, and 1 minute. Okay, an object O is placed to the left of a thin converging lens. Okay, here it is. F1 is the principal focus length on one side of the lens and F2 is the principal focus on the other side of the lens. Two rays from the object is been drawn. Okay, one is at the top, one through the center of the lens. Okay, how will you, what is the answer? Question they are asking. On the figure 7.2, locate the image O by continuing the path of each ray. So how will you draw the answer? That's a parallel to the principal axis. It is parallel to the, this line is parallel to the principal axis, one thing. So, and it is also away. So how will we draw? A line passing through F2. Okay, passing through F2, sorry, from here. Here it is, should be continued. Okay. 1 minute. From here to the center, then it hits here. And the second thing, if you draw from the center, it should not bend. It should come as a straight line and converge here. Okay, both intersects at the point. So how will you draw? Both intersects here. I am writing it's a inverted image. Okay, this is the image point. You will get a straight line for the second point which passes through the center of the length, and from the top it bends here, passes through the F2 point. Okay, okay, so this is the image you will get here. Okay, you should have drawn the arrow for the ray of convergence, so this way. Okay, both bends here and comes here. Okay, next question. 7.3 shows a prism producing a spectrum of colors from a narrow beam of light. White light it is. Okay, so from X the prism refracts the white light. State the name of the effect that produces the spectrum. What is the name? You will know. It's a very simple phenomenon. It is dispersion. Okay, in the spectrum shown there are 7 colors. Yeah, we know it's with GR, but we have to write from where? Top to the bottom. So red, okay, orange, yellow, green, reducing. Now next blue, okay, indigo, okay, 1 minute, indigo, and the last but not one is violet. Okay, with GR is from here to there we will go, but from maximum to minimum, red is the first one we are writing. Okay, from where to where they are asking, it's from X to Z, here to here, it's coming from this way. So starting from red we have to write it. Now next question, it is 8th question. Okay, what is the answer for the 8th question? We will go through the question first. Okay, here shows an arrangement for making an electromagnet. The electromagnet consists of a solenoid. It is in the center here of your core. Okay, the electromagnet is a temporary magnet. State one material which is suitable for the core of electromagnet. I think it's soft iron because of very high susceptibility. I have to write only the answer, but I am giving the reason. It's having very high susceptibility. Okay, and very low retentivity. For this reason it is been selected. Okay, we are using as a core. The second question, the battery is made from cells connected in series. Okay, each cell in the battery has an electromotive force of 1.5 volt. Okay, calculate the number of cells in the battery. So what is the formula? We have to find the number of cells. We know the electromotive force, how it is, how much it is. Okay, so battery EMF, that is this one here, battery EMF is given. So battery EMF divided by EMF of one cell. Okay, to get the number of cells. So battery EMF is given in the question, the previous part, it is 12 volt, divided by number of EMF is given for one thing, it is 1.5. so number of battery cells will be 8 cells. Okay, next question, the switch is closed. Okay, the direction of the current in the solenoid is as shown. Okay, it passes this way, arrow is been given here. Okay, there is a magnetic field around the electromagnet. State the name of piece of equipment that can show the direction of the magnetic field. It is, I think, plotting compass. Okay, yeah, we will use plotting compass for finding the direction of the magnetic field. It's a small bar magnet with the north and south pole. Okay, state the name of pole labeled X on the core of the electromagnet. Here, state the name of the pole which is north pole or south pole. How will you find it? Right hand grip rule. Right hand grip rule I am using. With that, when you are using, your thumb indicates the I am mentioning here, but don't want to write. I am mentioning the procedure what I have followed. Thumb indicates the direction of the poles. Okay, thumb indicates the pole direction. So according to that, it is north pole. Okay, so answer is north pole here. Okay, next question. C, the resistance of a solenoid is 8 ohm, current is 1.2, find the potential difference. So very simple, resistance is R is given, it is 8 ohm, current I is given, it is 1.2 ampere. So therefore potential difference formula is V is equal to IR. We know the basic formula. It is 8 into 1.2. What is answer? 9.6. Okay, unit is been given there. Ninth question, the figure shows the power cable for connecting a desktop to a computer to mainly electrical circuits. Okay, what is the question they asked in this? State the name of state the name of the 3 wires inside the power cables. We need, for the power cable, we need live wire. Okay, live wire, it's red in color. Okay, and then neutral wire, neutral will be black. Okay, and the last one is earth wire, it will be blue in color. I am mentioning only the colors here. Okay, nothing I am doing with this part. And usage is live wire carries the high voltage. Okay, carries, I will write it here. Okay, I will erase the colors and I will write it here one more, the usage alone. Okay, live wire carries high voltage. This one is the usage of the live wire and brings the current to us, and whereas neutral wire is providing return path for the current to flow in. It provides a return path, voltage to current, it will convert here. Okay, from the return path for the current to flow in, for a return path for the current to flow in, okay, into the computer part. And the third one is the green charge, green color earth wire, no charge it will be carrying, no charge for the earth wire. Okay, it's only for the safety purpose. Okay, next part of the question, the cable is designed for a maximum of 13 ampere. Suggest one hazard due to the current of 30 ampere in the cable. It is designed only to 13, but we have decided to carry 30. What will be absent? What will be happening? It will be overheated, one thing, or insulation will be melting, or burning. Basic things. Okay. Okay, B part question. There is a transformer in the desktop computer. Okay, it's from there. The input voltage to the primary coil VP is 230. Input voltage. Okay, they have given VP 230. I am not writing the unit, I am writing the basic part. Okay, NS, NP is 720, NS is 50. So we know the formula, it is VP by VS equal to NP by NS. Okay, so from that part VP is 230 divided by VS equal to 720 divided by 50. So on calculation and moving here, how will you get? It is 230 into 5 divided by 720. So your answer will be 16 volt. Okay. Next question, the current in the input coil of a transformer is 1.4 ampere. Calculate the input power to the desktop. So how will you calculate? We know input coil. Okay, current is known here 1.4 ampere. For the power formula, power is equal to voltage into current. Okay, so it is voltage is how much? Here it is given here 230 into 1.4. It's a primary coil input, so I am using it. So it is 230 into 1.4, 320 volts. Okay. Next question, 10th one. The nucleus of a strontium is 90, represented in the nuclear notation as shown. Calculate the number of neutrons in one nucleus of strontium. Okay. Here 90 represents at the top, it is proton plus neutron value. Okay. So 38 is proton value. So number of neutron we have to find out separately. So 90 minus 38 gives, I think, 52, right? 52 is the neutron answer. Very simple. Determine the number of electrons in one atom of strontium 90. Number of electrons, how will you calculate? It is electron number, proton or electron number, it is 38. Okay. The next part of the question is strontium 90 decays by emitting beta particles. Describe the nature of beta particles. High speed, one thing. Okay, beta particles have high speed, high energy of electrons. That's one thing. Then then one more thing is ionizing power of beta particles is 100 times lesser than the alpha particles. You can write this one also, so it don't create any issues to the human tissues. Okay, one more point if you want to write here, I will write ionizing power, okay, of beta particles is 100 times lesser than alpha particles. So don't harm the human tissues or live tissues. Okay, this is one other point you can write if you want to consider. So next question, strontium-90 decays with a half-life of 29 years. A sample contains 16 mg of strontium-90. Calculate the time taken for strontium-90 to decay until 2 mg of strontium-90 remaining in the sample. Okay, I'll erase this part, okay, because I have to calculate here, that's all. Okay, so for decaying, how much it takes? Half-life. So in the half-life, first half-life I'm typing, okay, first half-life 29 years it is, okay, years I am putting here. How much it decays? From 16 mg it decays to half, it is 8 mg. Okay, in the second half-life, okay, it is next 29 years, so it will become from 8 mg to reduce to half, it is 4 mg. The third half-life, okay, from 29 years again it takes, so from 8 mg to reduce to 2 mg. So totally 3 half-lives it's taking. So totally how much? 87 years. Or 3 half-life it is taking 3 into 29 years. Sorry, I made it as 27. 29 years. Okay. So 1 minute, I'll write it clearly so that you don't want to confuse. Okay, 29 years. So automatically 87 years. That's the answer for this question. Okay. Next question, 11th one. The sun is a star in our solar system. 8 planets orbit the sun. State the name of 2 other categories of bodies in the solar system. What are they? There are so many things into account. I will write something which is you can write whatever you want. I will write one thing is asteroid. Okay, asteroid, and second thing can be comet. Other things may be dwarf planet. If you want to write anything, it is also right, dwarf planet, and whatever, moon we can write, I think, yeah, moon, I remember something, and then meteoroid, I think something, so I remembered writing here. Okay, these 2 is right, that 2 if you want you can write it. State the name of the galaxy that includes in our solar system. Very an easy answer, it is Milky Way galaxy. Okay, describe how the light from the distant galaxy gives evidence to support the Big Bang theory. So how can we write? The red shift, okay, that's the thing we have to remember here and write it. Red shift of distant galaxies and cosmic wave background radiation. This is the 2 piece evidence to support the Big Bang theory. One thing is red shift, okay, of distant galaxies. Second one is cosmic wave, cosmic microwave. Sorry, I mentioned this wave. No, it's cosmic microwave, background radiation. Background radiation are the two piece evidences. Okay, this is mentioned as CMBR. Yeah, this is the two piece evidence to support the Big Bang theory. So one thing, redshift is the emit the light. Okay, how can we define it? Redshift is the light that moves away from us. Its wavelength is stretched out, so the object appears red. Okay, how will you define redshift? I'm making clear here redshift alone. So redshift is the light that moves away from us. Okay, away from us, so wavelength is stretched. Automatically it object appears redder. Okay, this is the condition for this one, redshift, and the light from almost all the galaxies are redshifted. Okay, these two are the conditions to support the Big Bang theory. Okay, from this the paper ends here. Thank you.